Welcome to your first lesson on electromagnetic radiation. And basically, this is just a quick lesson to help give you the background so that when the stuff that we do in class, we'll be able to go much deeper and spend more time in class developing the higher level understanding skills. So, what we did last day was we looked at a variety of things. We talked about plants, we talked about X-rays, we looked at satellites, we talked about cell phones, and we talked about the sun and microwaves, and we said that there is a common link that links all of these things together, and we did some brainstorming, and we came down to the conclusion that the thing that links all of these things together is something called electromagnetic radiation. So the question is, well, what is electromagnetic radiation? How do we use it? Okay, what are some characteristics of it? Why is it so important to plants? Why is it so important to satellites, X-rays, cell phones, sun, microwaves? How can your eyes detect it? Different things like that. So that's our goal kind of as we work through these things. So the first thing here that we're going to do is we're going to look at a person by the name of Maxwell. Maxwell is kind of in that league of Einstein and Newton and those really important physicists that paved the way for us. And his big contribution is what we call electromagnetic theory. Basically, what Maxwell did was he looked at a couple experiments already done in physics. One experiment that we've already covered in this class is electrons moving through a wire. Okay, so we've got electricity, and what Oersted discovered was it creates a magnetic field around this wire. Okay, so that's the first thing. Electricity can create magnetism. The other one we also discovered in our previous unit, and that's if you took a magnet and you moved it towards a loop of wire. And basically what we learned from Lenz's law in the last unit is that as you move a magnet towards a loop of wire, it ends up creating a current in this wire. So we've got electricity in Oersted's creating magnetism. We've got Lenz's law in the second one where a magnet, a moving magnet, a changing magnetic field creates a current. So Maxwell brought these two things together and said that changing magnetic fields actually create changing electric fields. And guess what? The flip is also true. Changing electric fields produce changing magnetic fields. Okay? And if you think about this, if a magnetic field can produce an electric field can produce a magnetic field, once you get one of these going, it will continue on infinitely because that changing electric will produce a changing magnet, which then actually recreates another changing electric, which then reproduces another changing magnetic, and just goes back and forth, back and forth. So Maxwell created this picture of EMR, which looks like this picture on the top. Just to get your idea around what's happening here is the direction that this wave is traveling is from like left to right here. Okay, so the wave is going to your right. Okay, and what you can think of this light wave or EMR or microwave or whatever type of EMR radiation it is you can think of it as a changing electric field, which is moving up and down. Okay, so think of this as moving up and down. So that changing electric field creates a changing magnetic field, and think of the magnetic field as moving into the page and out of the page. So it goes into the page and then it comes out of the page. But once this changing electric field creates the changing magnetic field, that magnetic field starts recreating that electric field, which then starts recreating a magnetic field, and they just go back and forth like a wonderful little dance. So you need a three-dimensional picture to make sense of this. So this is our goal, to learn about this wave. And if it's a wave from Physics 20, we should understand that waves have certain behaviors. They should do things like interfere, they should diffract, they should refract, and they should polarize. So that's kind of what we're going to do for the next 10 days or so, is learn about EMR and learn how it behaves like a wave. A couple things about waves that we need to know from Physics 20. First one is we need to know about frequency. Frequency is how many cycles happen in a given time. So if I have a wave like this, okay, what ends up happening is from here all the way back to this wave starts going up again as it crosses through the equilibrium point. This is what I would call one wavelength. Okay, so it's the distance it takes to recreate itself. So how many times this wave recreates itself in a given time is what we call the frequency. Okay, so if it can do 2 waves in a second, we would say the frequency is 2 hertz. If it can do 3 complete waves in a second, we would say it is 3 hertz. Okay, so that's wavelength. Okay, is the distance from one part of the wave to when it repeats itself. Probably the easiest spots to actually calculate wavelength is actually from crest to crest here, or from trough, and if we've got actually a good trough here, from trough to trough, and that's the wavelength. Okay, next thing, EMR, this interesting value that it has actually a speed when it's in air or when it's in a vacuum, and it actually travels at 3 times 10 to the 8 meters per second. Doesn't matter what type of EMR, okay? Doesn't matter, you know, where the EMR originated from. When it's in air or a vacuum, it travels at that speed, okay? And the last thing that we're gonna play with a little bit later is we've got this equation, and we're gonna use it a fair bit in this course, that the velocity, okay, of the wave, which we know is just 3 times 10 to the 8th, okay, is equal to its wavelength, how long that wavelength is in meters, times its frequency, how many waves happen in a second. And if you calculate that, you actually get the velocity of this wave. So that's going to be an important equation as we work through this. So just a quick kind of going through what is EMR? Like what types of EMR do we have out there? Okay, and this is actually characterizing all types of EMR are just electric fields and magnetic fields oscillating back and forth. Okay, but the key difference is how long is that wavelength? If that wavelength from there to there is really long, like soccer field long or house long or even baseball long, we call it a radio wave. If that wavelength starts getting a little bit shorter, we call it like, you know, smaller than baseball, about the size of a period, we call it microwave radiation or microwave EMR. If it gets even smaller and it's like this, the wavelength is actually the length of a cell or a bacteria, it falls into this world called infrared radiation. Now, this is the part that we're really interested in because this is the part that my eyes can detect. Is this what we call visible electromagnetic radiation? And it includes all the colors that are in the rainbow. So Cat in the Hat once taught me this, Roy G. Biv. Okay, and as I was watching Cat in the Hat, R stands for red, orange, yellow, green, followed by blue, indigo, and violet. It's the rainbow song for you. Okay, and so you should know the colors in their order. And I want you to also know that red has about a wavelength of about 750 nanometers. That is a must know. You have to have that memorized for red. And on the opposite end, I want you to know that violet has a wavelength of around 400 nanometers. Okay? So these are really important. I need you to remember the order of the colors, but I also would like you to remember that red is longer. It's next to infrared. Makes sense. And violet is shorter, okay? And it's actually next to ultraviolet. After ultraviolet, as you keep getting shorter wavelengths, we run into the world of X-rays, in which we're fairly familiar with. Okay, they have lots of medical applications. And we've got gamma rays, which are kind of that bad type of radiation that when a nuclear reactor gives a harmful radiation, it's often in the realm of gamma rays, which can be really, really dangerous. Okay, so this is what I need you to know. I need you to know all the different types in order. So radio, micro, infrared, visible, ultraviolet, X-ray, gamma ray. You need to know those in order, and knowing that radio is the long, Gamma rays are the short wavelengths. And I need you to remember red and violet and their wavelengths. Okay. Just a couple quick things here. This is the same kind of table that I put in your notes so that you've got a copy of it. How do we create EMR? Well, we simply said we need a changing electric field. Well, how do we produce that? Well, all we do is take a charged particle, okay, or a charged object. So if I had a charged rod, let's say it's positively charged, it's creating an electric field. And we know that that electric field is going to radiate outwards from our second unit in this course. But what we want is a changing electric field. We want this to be changing. So how do we do that? Just start moving this thing back and forth. If you start shaking a charged object, it will start changing the electric field around it, which will create a changing magnetic, which will create a changing electric. So you're going to notice the production here. How do we create different types of EMR? We take things like electrons or charged particles and we accelerate them up and down a antenna. So radio waves, what do? We take electrons, accelerate it up and down. Microwaves, so what do? We've got special tubes that accelerate them up and down even quicker. Infrared, what do? Well, you've got charged particles in your body that are constantly vibrating really, really quick because you have heat. And basically what happens is it creates an EMR, electromagnetic radiation emitting from you. And we are going to spend a lot of time in our last unit looking at how these types of EMR are created. They have to be accelerated really, really quickly. And so there's some special things that happen inside the atom that does that. Okay. Last thing I'd like you to do is just have a little bit of work with the formulas. So remember, this is our universal wave equation. So let's say I gave you something like a wavelength for violet is 400 nanometers. And I said, hey, what's the frequency? And the question is, this equation becomes really powerful in taking a wavelength and figuring out the frequency, or taking a frequency and figuring out the wavelength. Because when we use this, V equals F lambda, our velocity for EMR, we know. It's 3 times 10 to the 8 meters per second. This is in your formula sheet. The frequency for this ends up being what we're trying to find out. So I'll just call it F. And the wavelength in this case is 400. But remember, we want it in meters. Nano means times 10 to the negative 9. And that's also in your formula sheet. So just take out the n, replace it with times 10 to the negative 9. When you end up doing this, 3 times 10 to the 8 divided by 400 times 10 to the negative 9 ends up giving you a frequency of 7.5 times 10 to the 14 hertz. So I took a wavelength, I figured out the frequency. And think about this. This is a pretty huge number. Violet light completes a wavelength this many times every single second. Okay? Once you know the frequency, we've got equations from Physics 20 which allow you to calculate capital T, which means the period. What is the period? It's just the time it takes to make one cycle. So you can use that formula if you need to do this. And I've also thrown up this equation. And most of us would recognize this as a really important fundamental equation that we learned in Physics 20. And it describes anything moving with uniform motion. EMR travels with uniform motion because it travels at a speed of 3 times 10 to the 8 meters per second in air or in a vacuum. And it stays at that speed. It's not speeding up, it's not slowing down, that's its speed, so it's uniform motion. So if I'm ever calculating a question with that speed, I'm going to use this equation because it's uniform motion. All right, last thing that I'm going to get you to do. Okay, thank you for listening. And what I would like you to do is you've got 3 questions at the end of your booklet. Please answer these 3 questions, go to the Google form, submit your answers into the form, and please write a reflection, and we'll see you in class tomorrow, and we're just going to keep building our understanding of EMR. Thank you, class. Have a good night.